capacity.
Yeah, aluminum calorimeter filled with that amount of water. Ice, this is more difficult. Ice, equilibrium. Unknown metal cube, 300 gram temperature added to the calorimeter. The final temperature is 30. Okay, so you have three things at three temperatures. Ice at what's the temperature of the ice? Ice is at 0 degrees, right? 0 degrees Celsius. And water at we don't know the temperature of the water. Fuel and aluminum, four things, not just three. So we have 1, 2, 3, 3 specific heat. Final temperature of the water is 30. Water, we don't know its initial temperature. The next thing is the iron metal cube at 250 degrees. And calorimeter container. Can I move this words? No. Calorimeter. Initially at the same temperature with the water. Melting ice. Okay. In thermal equilibrium. Okay, so the point here, in equilibrium, where is it? In thermal equilibrium, the word here, okay? In thermal equilibrium with the melting ice, meaning the initial temperature of the mixture, temperature T of the water is also 0 degrees, and the calorimeter is also 0 degree, okay? Because of this keyword, thermal equilibrium. Final temperature 30. Final temperature T final is 30 degrees. The heat, of course, will transfer from the cube to the water, and from the water to the ice. Heat, and of course, we also transfer to the calorimeter also. Okay. Yeah. Defines the heat capacity. Okay. Question A, easy, just theory. Amount of heat to use this equation, C is Q over M delta T. Okay, amount of heat to increase the temperature of unit mass 1 kilogram by 1 degree, 1 Kelvin. Yeah. Question B, determine the capacity of the metal. Okay, assuming negligible energy losses. Okay, calorimeter. Fusion of water, capacity aluminum, heat capacity water. Okay, the heat lost by the cube will be equal to heat gain absorbed by ice, water, and calorimeter. Three things. Okay, I will write the equation here. The heat lost by the cube, the mass of the cube is 300 grams, which is 0.3 kilogram, multiplied with specific heat capacity of it, which is what we need to find. Okay, need to find it here. Multiply with the change in temperature. Final temperature is 30. Initial temperature is 250. Okay, this is heat lost by the cube. Okay, will be equal to heat gain by three things. Water first. Amount of water is this thing. 230 centimeter cube, which is 230 gram, which is 0.23 kilogram water. Okay, times the heat capacity water 4,184 times final temperature is 30, initial temperature is 0, like that. Added with the heat gain by the ice. Heat gain by the ice, final temperature. You need to melt the ice first before increasing its temperature from 0 to 30. So the heat gain by the ice is 2 parts. Yeah, 2 parts. The amount, the mass of the ice is 75 grams, 0.075 times its latent heat of fusion, 3 times 3, 4 times 10 to 5. That is the amount of heat to melt it, and then add it with the amount of heat to raise the temperature by 30 degrees, okay, of water. After melting, you use the heat capacity water, okay, 4184 in time 30 also, meaning similar to the water here, okay, but this is a little small amount of water after melting, okay, and heat absorbed by the calorimeter, mass 0.05, heat capacity 910, and temperature 30. Okay, solving is the equation. Just put all the numbers into the calculator and solve for C, which is an X variable in calculator. Okay.
Yeah.
You can find value of C. Excuse me for 1 minute. I need to go to the bathroom. So
I got 980.
What is C?
980.
80. Okay, joule per kilogram per Kelvin. Let me check if it is close to some kind of metal.
I think it is because the aluminum is 910.